so far we have studied mechanical property. We started with the texture. What is the overall texture all about? What it encompasses? It encompasses rheological viscoelastic natures, rheological properties, microstructure, everything is involved. And that's what the first lecture we did. And then we moved on to mechanical properties, where we looked at the elasticity of the material, modulus of elasticity, force deformation will not be sufficient. You have to do stress and strain. And then we looked at the when you load it, when you apply some type of force, stress is applied on the area you apply, and then that can get transferred. You convert that into strain, so stress over strain. And then we looked at the when you do the deformation, and then the other side of the material, it get expanded. So there is lateral strain also. So you need to account for both the transverse and lateral strain, and that gives you the Poisson's ratio. And that information will be useful when you try to look at the how porous material is, and that will have an impact on the actual modulus of elasticity value and further analysis of the elastic properties, what we are trying to do. And then we looked at the elasticity and plasticity, because when we did the analysis, we were just looking at the solid material and elasticity of the material. So it's not, the foot materials are not purely elastic material, they are viscoelastic or elastoplastic when you think about that. Because the viscous component, we didn't discuss about it until next day, which was yesterday. So elasticity and plasticity, there are different ways you can measure the degree of elasticity and plasticity. Either you can take the area under the curve or the strain values. Typically, area under the curve will give the accurate information compared to strain values. That's what we looked at in the example problem. And then we looked at the tensile test, which has a similar equations like compression test. And then we looked at the brittle and ductile behavior. Brittle means it snaps immediately. Ductile means it's elongated and then it breaks. And that's where we stopped in the first day of discussion. And then second day, yesterday, we started with the viscosity calculations, viscosity measurement, and we looked at the Newtonian and non-Newtonian behavior. It's basically, in viscosity, what is happening is liquid layers moving apart each other, they are shearing each other, and that gives you the, when they, depending upon how fast they move, how slow they move, their shear stress will be different. Newtonian fluid will have a linear shear stress with respect to shear rate, and that gives you the viscosity value. So Newtonian fluid will have a one viscosity number, but the non-Newtonian fluid will not have only one viscosity number. If you consider one shear rate for everything, you get one viscosity number. But you have to first characterize your fluid and make sure that it's Newtonian or non-Newtonian. If it's non-Newtonian, then you need to properly characterize and find out the power law parameters and use that power law parameter value for comparing different samples, whatever you are trying to develop in product development or in terms of the scientific knowledge gaining. So that's what you should do in terms of viscosity measurements. And from there, we went to viscoelastic property evaluations. Within the viscoelasticity, there are different ways you can get the viscoelastic properties. One classic example we talked about is using the compression test itself and how that one gives you. So when you do that, viscoelasticity, we are talking about both the viscous nature and the elastic nature, and there are ways you can do that by combining both the spring, which is elastic, and dashpot, which is viscous. So if you combine spring and dashpot in series, that is the Maxwell model. If you combine spring and dashpot in parallel, that is your creep. Creep is all about applying the load and then monitoring the deformation, creeping behavior, strain value. That's what you do in the Kevin-Waggett model, which is the spring and dashpot is in parallel. And then when spring and dashpot in series, then that's called Maxwell model. Primarily what you do is that's called stress relaxation. So basically you deform the sample to the constant deformation and you keep the stress, you monitor the stress with respect to time. So sample will relax, so the stress you are applying from the maximum value, it will decline, and you can model that, and from that you can calculate your theoretical viscosity, and that's what we did yesterday. And then this morning we came and we looked at the dairy products. Primarily we looked at the texture profile analysis, and we did some example problems. 2 samples we looked at it and find out how different they are, what are their hardness values, cohesiveness, cohesiveness, springiness, gumminess, and then what else? Fracturability was there, hardness was there, gumminess, resilience, cohesiveness. Okay, so everything we calculated and we manually went through the process and find out how we can calculate that, and how they will be they will characterize themselves, and that's where we did. And then after that we looked at the after TPA we took the functional properties, where we looked at how to measure the meltability, softening, and then stretchability. So those things we looked at it. Now I like to spend some time in terms of different measurement techniques in dairy products. Most of the things we already discussed about it, but it will be again review of the material, and then we can discuss more in detail if there are any questions anybody need to be answered. Is it a proper overview so far? Okay. What are dairy foods? We had a small overview also before lunch. So we talk about we start with the milk. Milk is coming from cow. Cow is in the farm, and that's where it gets food, some type of ration, whatever humans need to get. So the milk has its own composition, and when they start with the milk, you can characterize the milk, you can measure the viscosity of milk and what are the properties in the milk, and then depending upon the product you want to get, you can modify this milk by removing whatever you want to remove. You want to remove the fat, you can take the fat out, you can remove the protein out if you want to. There are ways you can do that, and that's what they do. And when they do that, then the raw material becomes different. So there are some measurements you have to do so that you standardize your milk before this milk get processed for further value addition or further product development. So start with the milk, and milk goes through the different processes. So for example, milk primarily goes through the making the cream, because milk is starting material, and getting to the cream is probably one of the fastest route, and this cream can be used for further cooking and other product development work, and then this milk also gets converted into cheese. When the milk gets converted into cheese, you get a lot of whey, cheese whey, and that has a lot more value these days compared to 20 years ago. Even 20 years ago, this whey was a waste product. That time the value of that whey was not realized, how valuable the whey could be. Is everybody familiar with the cheese whey? Okay. So now cheese whey is the main product and the cheese is secondary product. Does everybody agree with that statement? There are processing plant. They process the milk just to get cheese whey, and that is their primary product than the cheese itself. I mean, you have to get the cheese anyway before you get the cheese whey, but whey has more value these days than the cheese itself. And from the whey, they can produce whey protein concentrate or whey protein isolate. You all know the difference between isolate and concentrate? Which one has a higher protein? Isolate has a higher protein because they do a lot of concentration with that, and then they get its whey protein isolate, which has higher protein and better functionality. Where it is used, where is the protein concentrate or protein isolate gets used? Emulsifier, better functionality. Protein supplement. People drink protein drinks. Huh? In beverage also.
Alternative meats for plant-based meat products we use today.
People use it for making plant-based proteins, meat products, meat substitute, not meat product, meat substitute. Where else? It's also used in the pizza base, so that it has a better functionality. Not that much, but to some extent it gets used, and it has a better functionality. So wherever they need to have better functionality, that's where the whey protein concentrate, whey protein isolate get incorporated, and that makes the final product more value-added product with a better functionality. Then from that you can also make butter, you make ice cream, yogurt, and things like that. But main products are cheese and whey protein concentrate and whey protein isolate. So these are most of the type of foods in Western societies. Now it's everywhere, not anymore only Western society. Every country, every region use this one. And main thing is dairy foods has a rich in many essential vitamins, minerals, protein, macronutrients, and have a significant function such as the anti-cancer, antioxidant functions. So that's the main reason. So some people have a issue with the milk also. What was that issue? Lactose intolerance. We like to see you can eat everything, but those days are changing for worse. It's not better, it's getting worse. So I don't know, maybe in olden days we didn't check for these things before, but now it is getting more pronounced. People cannot, they're allergic to this food or that food like that. So there's a lot of limitations how much they can consume, but on the other hand, they have other varieties also. It's not the end of the life, right? I mean, if they cannot drink the milk, they can always drink other type of milk. What other type of milk available in the market? Soy milk, almond milk, yeah.
Pea milk is also now getting.
Millet milk, correct. Millet is getting very prominent these days. Even in US also, IFT is promoting millets. How many of you know about IFT? What does IFT stand for? Institute of Food Technologies. So it is ift.org. If you get an opportunity to attend this IFT annual meeting, I strongly encourage you to look for opportunities. I know it's expensive to travel to US, but there are universities, there are institutes, they provide international travel opportunity for some of the elite students. And then if you show good academic credentials and then submit abstract and present in the meetings, you will have opportunity. Just for your information, moving forward next 10 years, IFT annual meeting will be in Chicago, Illinois only. Every year it's going to be Chicago. So even if you cannot find opportunity to go next year, doesn't matter. You can wait until you find the opportunity. And at least in your lifetime, and I cannot say lifetime, but in near future as much as possible, try to attend at least one IFT meeting. And it will be a very eye-opening event for you. You will see a lot of industry folks, and there will be a lot of career opportunities with them, and they look for a lot of good people to work in their industry. This is one of the great gala event happening every year in US, and this is probably the major event happening worldwide where they get 40 to 50,000 people attending this event in 3-day conferences. So it's a great event to attend, and it will be a great opportunity to network with the people also. So just a side note on that one. IFT.org is the place you want to visit, and there is a lot of opportunities, a lot of networking. You can connect with the people, and you guys can probably have a club or something here also. There is a lot of opportunity for that also. Both Poonam and Sushil knows about this, and they will be able to help you out also. So, any questions on IFT? Okay, when did the dairy food industry evolve? Basically, 1880 started with the mechanical separator and extractor for determining milk fat content, because they were able to separate the fat, and that's how they were started doing the processing the milk. The first method of determining the milk fat content was the modified ether extraction method developed by Rossi in 1892. So now you see what's the background. So I think it's evolved, and then you guys have a different standard method now, because ether extraction method may not be very environmental friendly method, and that also involves a lot of chemicals. So during the 20th century, more sophisticated techniques for the fat composition analysis of dairy foods were evolved, such as gas chromatography, optical spectroscopy, etc., etc. So there's a lot of other measurement techniques used in the dairy food industry. We talked about this one, rheological characteristics of dairy foods. Again, rheology is used to define the consistency of different dairy food products based on the viscosity or the viscoelasticity properties. Viscosity, we talked about it. You can use the rotational viscometer to measure the viscosity of different dairy products. You can also use the rheometer to measure the characterize the viscosity and also viscoelasticity of the material. So in practical applications, rheology denotes the viscosity determination of material structure, and again you can correlate with the microstructure of your different products, either ice cream, butter, or cheese, anything like that, or for that matter milk also. We talked about this one, ATS rheometer. This is what we have, rheometer wise, measure the rheological characteristics of dairy materials. And you can also use a stress relaxation as a fundamental test to study the viscoelasticity. And it can be performed in uniaxial tension, compression, shear, bending, and torsion. Most of the time they use compression, and you can use your textural analyzer for doing the stress relaxation test. How do you do the creep test? Correct. But in terms of the measurement technique, how do you conduct the creep test? Constant force. you have to apply the constant force and then monitor the deformation. So it has to be done separately. There's no instrument for that. One way you can do that is, one way is done is, I'm going to show you whatever I showed you before for the melt test. Same instrument can be used for creep test also. Not creep test, sorry. Yeah, creep test. So this is our rheometer. Again, this can be used for viscosity measurement alone or viscoelastic characterization of your material. And more importantly, you can also use it for heating and cooling of the material. So you can characterize the material as it is when you are heating and cooling. The instrument you have the same setup, right? You have provision to heat and cool. Oh, okay. How high temperature you can go? Celsius? Okay, 150 degrees Celsius you can go in this rheometer. Oh, okay, that's fine. So again, it's a sinusoidal wave application, and then you get the elastic modulus and viscous modulus from the complex modulus value. So you have the complex model value G star, and then phase angle. So phase angle is 90 means more viscous. Exactly. If it is 90, more viscous. 0 means elastic. Purely elastic is 0. Purely viscous is 90. Typically, viscoelastic materials you get from 0 to 90. In fact, dairy products you typically get anywhere between 50 to 70 as the right. So some dairy products you can go up to 50 to 70. Some dairy products will probably have a 20 to 30 like that. So that is a range for the phase angle. Then we looked at the modified Scheibert test, where you can use low temperature for the meltability of cheese. It's measuring the spread area instead of the maximum diameter, because previously it was done at 150 degrees heat oven temperature, and they usually measure the maximum diameter instead of the area. So there is a lot of new developments here, and when you put it in the aluminum plate, you get a better, more spread. So and you get the better differentiation between the samples, because at the end of the day, whatever material characterization you are trying to do, you should be able to make it significantly different than your control sample. So that should be the idea. So the instruments, measurement techniques you use, they should be able to differentiate better. If it is, that's what it is, you should be able to differentiate better than your control sample. Because sometimes if the numbers are so close to each other, you won't be able to make a significant difference. So if we can make it, if the range can be more wider, then you will get a better differentiation from the other control samples. This is a melt profile test we talked about this morning. I just want to reinforce here in terms of the purpose of this test, where you can see the flow and also sometimes you measure the temperature. So from this you can get the softening rate, melt rate, softening temperature, melt temperature, and the complete melt temperature, and those kind of profile information you can get for the meltability of cheese. This can be used for doing the creep test also, where you have the two plates and then you can put the constant force on top of your sample and you can monitor the deformation. So if you have a similar setup, you can do the creep test for any of the samples you have. This is what the results you will get from the melt profile, similar to texture profile test. So you will get the temperature profile of cheese, at the same time flow characteristic, how the cheese is flowing when there is no constant temperature. So temperature of the cheese keep changing and then flow is occurring like that. There are three regions you have. and from that you can find out the softening temperature, melt temperature, and complete melt temperature, things like that. So it's more elaborate characterization of cheese itself at high temperatures. Another method is melt meter. It's a modification of Seibert test or the modification of melt profile test. It's a controlled heating, uniform temperature of the cheese so that you heat the cheese and then measure the flow characteristics. That's what is happening here. Compared to previous melt profile test where the cheese is getting heated and also following the profile. So this is the main difference between this test and this test. This test, cheese is heated, put it in the well, and then the whole thing is raised up, and then you measure the flow of cheese at particular temperature. Make sense? So cheese already in the temperature, and then you follow the profile, follow the flow of the cheese. Some of the typical results you get from here is the change in height with respect to time of flow at different temperature and different fat level, different moisture. So you will have different samples. You can differentiate between the samples. Some melt faster, some melt slower. So those kind of characterization you can do, differentiation you can do. This is the ultimate moisture melt profile you get. It's a function of viscosity and shear rate. So from here you can find out that as viscosity is decreasing with respect to shear rate, which means that it's a shear thinning, right? Viscosity decreases with the shear rate, shear thinning. And that's what it is in terms of the melt also, because this is, we are talking about, it's not cheese, solid cheese, here it's melted cheese. So melted cheese, how it is flowing. Any questions on this analysis, measurement technique? Another method is stretchability. For melted cheese, stretchability is an important functional property. So here what is over 60 days of storage, and then you are trying to monitor the stretchability of cheeses. So here they use the melted cheese again, and then they are stretching it out. So at day 1 and day 10, it's a very high stretchability, and then as you age this cheese, it's become softer, the stretchability decreased because it cannot stretch a lot more, so it get broken into during the test itself. This is a typical compression test. So you can measure the hardness, firmness, rigidity, and resilience and all. This is not actually compression test, it's kind of bending test. But if you look at the attachments here, you see a difference here, right? It's a wedge-shaped platform, and then cheese is placed, and you force the probe into the cheese, and then you can measure how the cheese is breaking while you apply the force. This kind of test can be done in compression as well as tension and bending and shear test. When we talk about the typology, we'll talk more about the shearing, friction, those kind of things, because that is what's happening during the sensory test, where it's not just only compression, it's also how the material gets stick to your teeth and also your tongue, and there's a lot of other things involved when you do the sensory evaluation, or when you eat the food, what is happening while you are eating the food, and what kind of senses you get. So what are the factors affecting the dairy foods functionality? Starting from the milk properties, going into the composition and post-production processing. These are all the several factors. So stage of lactation also play a role in terms of the quality of the milk. Feeding, milking season also play a role. Depending upon how many servings cows get fed, that will have impact on the what kind of milk they produce. And breed of the cattle also play a bigger role. You don't get the same milk from different cows. So, but they are all clubbed together sometimes, and they try to mix all the milks together and then use it for further processing. And whatever in the milk itself, the moisture content, fat content, salt content, pH play a bigger role when you try to produce product using the milk. And in terms of post-production processing, aging plays a bigger role. As you age the product, you get softened because of the protein proteolysis happening, and also freezing will affect the products you produce, and the heat processing also play a bigger role. So these are some of the factors affecting the milk itself and the post-processing parameters. Now let's look at the microstructure. It plays a bigger role in terms of the understanding how the material behaves. The microstructural chemical components are grouped into granules, casein, micelles, proteins, globules, fat globules, gases or air, and they are dispersed in a continuous medium and can be analog aqueous liquid, liquid yogurt, or solid matrix like cheese. And it can contain other functional ingredients such as starch, hydrocolloids, gelatin, custards and creams. And a lot of times in the dairy products, they also add the other ingredients also, so that the final product will have better functionality. So there are a lot of other measurement techniques available, such as SEM, TEM, and Cairo SEM or environmental SEM. You all know that what is SEM is, right? Scanning electron microscope, and then transmission electron microscope, and then Cairo SEM or environmental SEM, so that the sample preparation for SEM, you don't have to do it in the environmental SEM. You can just put the sample there and take the images of the samples. Out of these three measurement techniques, instruments, which one is easy to do, which one is very difficult to do? SEM is easy to some extent, and which one is difficult? Cairo SEM is difficult? Cairo SEM is what? One by one? Cairo SEM is? Okay, so that's why it's called Cairo SEM. TEM is very difficult also, because TEM need a lot of sample preparation, and also you need to cut it into small slices, and that could be very difficult to do. Again, these measurements are two-dimensionals, 2D, right? Only surface thing you can look at it. But all your sample preparation, all the samples you are looking at in terms of rheological properties and everything, except for the dairy dynamic test, everything is more macroscopy, not microscopic thing. So that needs to be taken into account. Anybody knows about any other microstructure evaluation technique? Sam, ma'am? Any other?
Light microscopy.
Well, light microscopy is again the two-dimensional, right? Confocal. CSL, confocal laser scanning microscope. So it's called CLSM, confocal laser scanning microscope. The advantage of confocal laser scanning microscope is you can get the two-dimensional images, but you can go deeper into the sample. So you can get the sections of two-dimensional images and stack them, and then you will get a three-dimensional view of what's happening within the cheese itself, within your product itself. That's more expensive equipment, and it also it takes better more comprehensive analysis, so that you can get the three-dimensional images. So CLM is the more expensive equipment, but it can provide a lot more information about your product itself. So what you see here is the fat globals in red, and then protein, which is in green. This is for cheese, and this is for yogurt. What's the main difference between cheese and yogurt? Yeah, one is high in fat, other one is high in protein. Yogurt is more protein, more greener, and cheese is more fat and more red. That's what it happens, and that's what you see here. There's a lot of new technologies coming up for rapid test of dairy product. One of them is biosensor technology. How many of you are familiar with the biosensor technology? What is biosensor? There's a biological component which can be used to detect the whatever measurement, whatever thing you want to detect. So that's called the biosensor technology. It's an analytical tool that responds to the presence of a specific analyte through a selective biochemical reaction by producing an electrical signal. So you produce an electrical signal and it tries to pick up the specific analyte. And a lot of times the sensors are constructed from a bioreceptor, detector, and a processor. So typical biosensor technology involves all these components, and you can measure different ingredients in your process itself. So glucose, protein, lipid, fatty acids in dairy products can be effectively and rapidly determined by biosensor technology, such as galactose monitoring. That's what you see here, and also SPR biosensor for lipid, fatty acid detections. So there are a lot of new things coming up in the biosensor technology. Again, the important thing here is, like any other instrument, calibration is the key. If it is not properly calibrated, you may end up getting a lot more unwanted results. You may not get proper results from these instruments until otherwise you get calibrated properly and more frequently. The next one is identity and quality of dairy products. Basically, it's a determination of identity and quality of dairy products, important issue for food processors, retailers, regulatory authorities, and consumers. And there are a lot of techniques available for doing that. Some spectroscopic techniques, such as the near infrared, mid infrared, front face fluorescent spectroscopy, and nuclear magnetic resonance, they have demonstrated the ability to the determination of the quality and geographical origin of the dairy products. And nowadays, there's a lot of things coming up in terms of the, I'm trying to think, they are trying to monitor where the product is coming from, what kind of source it's coming from. RFID tags, and also I'm trying to remember the term for that. What do you mean? Intelligent packaging is there. Yeah, that's one way to do that. So you can monitor what is happening to the supply chain, and there's another term for that. No, yeah, active packaging, but the whole process, there is a term for that. It's similar to monitoring, but I'm not getting it. So, let's say the product is manufactured in US and you're shipping it to China. Traceability, exactly. Product traceability, so that they can know that nobody has nobody has changed the things before it reaches. So product traceability is very, very important thing, so that they can make sure that quality is there, and the product what they are getting is what they are expecting to get. So those kind of things are also coming up. I mean, they are very heavily used in these days, and it's very important for in terms of the dairy products also. And sensory analysis of dairy products. Most common sensory attributes dairy products such as flavors, taste, viscosity, and texture. Sensory attributes can be measured based on information received from the 5 senses: sight, smell, taste, touch, and the hearing. We are going to talk about that after tea break, where that will be the sensory analysis based upon texture. And then tomorrow we will discuss about the sensory analysis for the viscosity measurement. How do we do sensory analysis for the viscosity measurement? That will be tomorrow morning. After that, we will do the typology, and then we will talk about the advanced instrumentation. When I say advanced instrumentation, what is come to your mind? Advances in instrumentation. HPLC, GCs, okay, UV spectrophotometer.
Adult technology.
Well, yeah, adult technologies. Well, adult technologies primarily in terms of you are trying to combine couple of technologies together.
Yeah, it's like thermal and non-thermal.
Correct, yeah. But this one is primarily based upon what are the new technology there, like NMR, nuclear magnetic resonance, can be used for characterizing the rheological behavior. You do rheological behavior, but NMR studies can add comprehensive value to the studies. So we will be doing that. After the tea break, we will look at the sensory analysis for the texture measurements. Cheese ripening is a big deal. They go through a series of chemical, bacterial, and enzymatic reactions that are responsible for breakdown of protein matrix, which is protein proteolysis, and ultimately development of texture and sensory characteristics that are typical ripened cheese. What all things happening when you ripen the cheese? Aromatic flavor. So flavor components getting increased by doing the aging process because of the proteolysis, and that's very important in terms of the product development also. So that's what it says. Determination of the ripening of the cheese could help the cheesemaker better understand the biochemical kinetics of the ripening, and in consequence improve the ripening process. And also temperature, humidity, what they use it also helps the final product characteristics. So some of the new technologies they use: NIR, Fourier transform, infrared, low NMR. Any thought on it? Low NMR? I need to find out. I don't know what a low NMR means.
Low frequency of resonance.
Could be that, yeah, low frequency of nuclear magnetic resonance. So cheese ripening is a big deal, and they do and it does it differently in terms of what kind of product they want to get out of that, what kind of final product they want to get out of that. So that makes a huge difference in terms of the product characteristics. There are new portable instruments coming in the food dairy industries. One is called Milko tester, fat content measurement. Is the Gerber unit is similar to this one? No? How is the Gerber unit looks like? I never seen one. Oh, it's like centrifuge. Okay. Oh, okay. So basically, you grind the sample and put it there, and then you centrifuge it, and then it get the fat is dispersed out. And primarily use it for cheese? Milk? Oh, only for milk. Oh, okay. So so fat and water get separated out. Oh, that's why it's called milk tester. So milk name itself sells the milk. For protein profile, again for the milk, Pro Milk MK2 protein profile, obviously pH meter, we all know that, and then moisture analyzer. So these are all some of the units. You need to use it for proximate analysis for that matter. And so a lot of times, again, this instrument need to be calibrated properly so that you get the accurate readings. What's an unit called? Milko scan. Anybody heard about that? Most of you are aware of that. Milko scan. Name is MILK Milko scan.
Can how much the lactose?
Yeah, I think that's totally true for any food material for that matter. As long as it's coming, any food material coming from natural sources and it goes to the other processing facility, they want to make sure that what they are getting it so that they will be able to pay the right price for the product they are getting it. It is true for any product for that matter, not only milk, corn, soybean, wheat, everything get evaluated when they receive the truckload of material. And then based upon the what is in the material, then they will price it accordingly. And that's very important because that's a fair way to price it and also give credit to the people who is producing better quality product. How it works, that's a very good question. The name implies, looks to me like you have a milk here and then it gets sucked in and then, what's that?
Reading will show that
Oh yeah, reading will show, but the idea behind what Pooja is asking,
principle.
what is principle involved?
Difference in the density. It will have a lighter, so it will having a lower density.
But again, you want to have fat content in percentage, right? So how that density values get converted into actual percentage value, that's also important, right?
And then we have given standardized value to that machine, and as compared to that, it can give like that milk and that much fat and content.
Oh, okay. Yeah. Other thoughts?
Like how the lactometer works, that is the same principle, but it is more digital.
Oh, okay. Okay, let's go back to the digital thing, Machgar. Is the when we say digital, what does that mean? You get
More transparent.
more transparent. What does it come to your mind when he says transparent, more transparent?
Quality.
More accurate? Is digital is always accurate?
Approximately accurate.
Approximately. Okay, either it's accurate or it's not accurate. There is no approximately accurate.
It brings uniformity in testing. Suppose we take 1 liter petrol in Kerala and 1 liter petrol here in Rourkela. If that is 1 liter, then we have confirmed that we have got 1 liter petrol.
Correct. So that means it's accurate, right? On the other hand, if you see this 1.00005 like that, so does it mean that it's more precise? It's more precise, but it's more accurate? We don't know. More precise is there, more transparent is there. That's what you meant by transparent here. It gives you more precise reading. Yeah, but is it accurate? We don't know. So you have to do calibrations properly so that you get accurate readings. Is accuracy is important or precision is more important? You want both? Which one comes first? Correct. Accuracy comes first and then precision comes next. If you are able to get accurate result first, and then if it is precise, then it's good. The protein profile, okay. You are asking very good questions which I don't have answer currently, but I will get that information tomorrow for sure. How a protein profile works, how the milk code tester works, I will definitely bring the principle involved. In milk code tester only, they have 15 different versions of that. 15 different versions of milk code tester. This, that, like that. I think they have the same principle. This one is for the fat content, but they also have different other equipments which can measure other things, protein, moisture, everything else. So they have many different products, primarily for milk analysis. And you name it, they have that. Lactomat, Rapid Mini, Master Pro Touch, Master Pro, Master Economic, Classic. I think they use a lot of different new technologies, ultrasound, laser technology and things like that, and then that's how they come up with a new instrument to measure different properties, different materials. Okay, let's have some discussion about the sensory analysis. So far we primarily talked about instrument analysis of different things, texture, rheology, viscoelastic nature, viscosity and things like that, dynamic test, things like that. What is sensory analysis all about? So if I have a product, if I want somebody to tell me, I have 3 different products, like for example 3 different cheeses. If I give the 3 different cheeses to the set of people, and then I ask them to evaluate, tell me which one you like it. How they will analyze the product. If I just ask them, tell me which one is you like it, how they will evaluate it. Hold on. Go ahead. It will be a combination of texture and flavor characteristic from your point of view. By different rating? By differences? Different rating test? Okay. What do you mean by different rating test?
Different ratings, like we have to ask several questions and they have to give the description for each and every segment.
Okay.
Certain questions, like descriptive test.
Descriptive test where you tell them, okay, what do you think, what do you know about how firm the product is. So describe your thinking in terms of or how you rank it in terms of firmness. So product A ranking, product B ranking, product C ranking, and then you do that for different panelists, different testers, and then you take average number, and then you report it. Okay, that's one way to do that. So how we are going to correlate with the instrument measurement? Head-on scale. So there's a lot of different way you can ask them to evaluate. Yeah, okay. So you guys know the basics: diotri test, pair test, and differentiation test. Differentiate between one product and another product. Hedonic scale test. Okay. So you are aware of those kind of things. So we don't have to repeat that when we come back and talk about it.